The next section is simplifying and combining radical expressions. So two things that we've talked about. This first one, if we've got some root of a product, you can take the roots individually and multiply those roots. So the same thing on the second one, if you have a fraction with a root, that's the same as the numerator with that root and the denominator with that root. So for example, if we have the square root of 4a squared, well, the square root of 4 is 2. Square root of a squared is the absolute value of a. On the second one, it'd be the square root of 4 over the square root of a squared. So 2 over the absolute value of a. Now, we sometimes will have roots that don't come out nice and even. There is no number, a nice integer that when we square out we'll get 20. So what we can do is use a factor tree to break this down. So what this means is that the square root of 20 is the same thing as 2 squared times 5, because we have this 2, and the 5. Well, the square root of 2 squared is 2, and then we can just leave the square root of 5. Same idea with this one. We can break this into 9 times 8. So we can change this to the square root, and since it's square root, we want to keep things in squared. So we have 2 squared times 2 times 3 squared, because we have 2 2's, one by himself, and then 2 3's. Well, the square root of 2 squared is 2. The square root of 3 squared is 3. And then this square root is just square root of 2. So I'll have 6 root 2. Now notice we want cubed roots. So that means we need when things are cubed. So 24 can be 6 and 4. Notice this time I'm writing it in terms of cubes because we have a cubed root. So the cubed root of 2 cubed is 2, and then we're still left with the cubed root of 3. Now this one, we can break it out so we have square root of 11 over square root of 36a squared. Square root of 11 doesn't simplify nice, so we can leave it. But the square root of 36 is 6. Square root of a squared is the absolute value of a. This one, same idea. We can do the cubed root of 8a squared over the cubed root of 125y cubed. Notice this time, the cubed root of 8, we do know that is 2. However, we only have a squared, and so we leave that as the cubed root of a squared. Over, the cubed root of 125 is 5. Cube root of y cubed is y. Now on this one, the 98, we can break this down into 2 times 49. And 49 is 7 times 7. And then notice this b is b squared times b. So we can rewrite this as 2 times 7 squared times b squared times b. Well, the 7 and the b both have squares. And then we're left with a 2b in our root. On this next one, 54 can be 2 times 27. So we can rewrite this as, and it's a cubed root, so we want cubes. And now this y to the 5th, we can write that as y cubed times y squared. And so we've got a cubed here and a cubed here. And we're left with a 2y squared still in our root. On this last one, we're back to squares. And there's 2 ways we can handle this. the first way we can get our factor trees, and notice 50 is 5 times 10, which is 5 and 2. So we could write this as the square root of 5 squared times 2 times a times b squared all over the square root of 2a, which would give us 5 times the absolute value of b times the square root of 2a over the square root of 2a. These will cancel and we're left with 5b. Sorry, 5 times the absolute value of b. Or we could have changed it back to one big square root. And notice we can divide the 50 divided by 2 is 25. And these a's will cancel and we're left with 25b squared. Well, the square root of 25 is 5. Square root of b squared is the absolute value of b. Notice they're the same thing, so it doesn't matter which way. Now, in order to add and subtract, they have to be like terms, and in order to be like terms, you have to have the exact same radical. So let's go ahead and simplify each of these individually, and then combine what we can. So the 75 is 25 and 3, which is 5 and 5, so we'll have a 5 squared times 3. Which means this 5 squared, square root of that is 5, so we'll have 15 square root of 3, because you're already going to multiply it by this 3 that's out here. This second one, 12 is 6 and 2, which is 2 and 3, which will be minus 2 root 2 squared times 3. So this 2 can come out, so I'll have minus 4 root 3. And this last one, 48, 6 and 8, 2 and 4. So we'll have a 2 squared here, a 2 squared. So we'll have a 2 and another 2 that can come out. So we're left with 8 square root of 3. And now notice all of them have square root of 3, so we can add and subtract or combine our coefficients. So 15 minus 4 is 11. 11 plus 8 is 19. Root 3. This next one, same idea, but we're dealing with cube roots here. I forgot a -1. Now when we have the cube root of -1, it's a negative, so that'll cancel with this negative. And then we'll have 4x cubed root of 2x. Now notice they all have this x cubed root of 2x. So since those are all the same, they are like terms. So we'll have 2 plus 3 plus 4 is 9x cubed root of 2x.